You've obviously followed closely your careers on the engineering and project side and leadership side. How did you start working together, and why do you follow each other?
It wasn't intentional on my part. It's more of I keep getting calls from Chris or somebody that says, Chris went on to another job, I need you to come here and do that. So I guess we first started getting involved a lot with each other when you were working EOS, and we had an instrument project at one point, and I had a system engineering group where we had a lot of instrument engineers, and those instruments were very complicated, very big, took a lot of effort, and so there were an awful lot of times where it just, what's the latest problem du jour? Things like on MODIS, when fairly late in the game, discovered that the fact that you had clouds in a scene started giving you ghost images and other pixels, and who knows anything about this, and how can we figure out how to sort this out, because we really don't have time to go do that. And it was kind of built on a lot of experiences, but it really cemented a relationship that you're focused on getting this thing right. And it's not just enough to be within spec all the time. You really need to be able to sit down with a scientist and say, what does it take to really get the observations you need out of this instrument? Whatever the spec says, that's fine, but is it post-processing? Is it fixing the optics? Is it fixing the detectors? Whatever it is, and just go get the right resources.
Yeah, I mean, that was quite a interesting problem, in fact, the MODIS one, because it turned out when we had to work it, that it was something that came about because the instrument was so much better than previous instruments. In the past, having a very bright scene or a very bright pixel next to a dim pixel didn't mean much. Now, with the precision, we were 12 bits, 16 bits of precision, as opposed to what previous ones were, which were 6 or 7 bits, maybe 8 bits if you really were stretching the state of the art. Suddenly you had this huge problem. And as I mentioned earlier, one of the things that you have to do is you have to be honest. You have to, tell people where things really stand and understand what's going on. So we saw the problem. Mike's team, came in and helped us. We never hit it and went off and worked it. Had a lot of excitement getting to a conclusion. But that started a long-term relationship. Mike and I worked on a number of issues that came up, but that one was probably the first most difficult one. Probably the most fun was when we had to restructure EOS. That was most fun. And then as we moved up in management, it got less fun, but equally interesting, as we had to try and solve personnel problems across the center, and then come into the headquarters, where Mike and I worked together to set up the System Engineering Leadership Development Program, which I think is moving along really very well. So we went from really deep down technical things to looking across the whole agency.
People sometimes ask whether we're having fun at what we do, and I think the job description says we're allowed to have rewarding experiences. So, Chris makes a point about MODIS. It's got kind of an interesting legacy, because that instrument performed so much better than the minimum that were the specs, and it's now the gold standard. That because it performed so well, it was able to do its job so well. There are a lot of folks in the operational community across the whole government, as well as the scientific community, that look at that as that's become now the floor for what we can expect for future instruments. And if we aren't as good, at least as good as we did on that one. So it's an interesting way that the requirements progress. We find out that we can live with no less than what we used to think was going to be darn near impossible.